This is a digital resource which I created using the software GeoGebra, and this basically explains the way the locus will be plotted through this mechanism. As the crank rotates clockwise around point A, we can see the locus being created. The second resource was a physical resource. This is it here. So it's a pen placed inside a crank, and it goes around clockwise direction, and this shows the student what way the locus is created. My idea of this was that the students will create their own mechanism, and they'll be able to experiment with it to figure out what way locuses are created and what different restrictions can be put on it to create a different locus. This is the question that I've put forward for my peers. It's slightly difficult, but the peers must understand what a pivot is, what a rocker arm does, and the sliding link. So here's my question. So this would be given to the students and they would draw it out, and then the solution is it here, and this will be drafted. So I'm here with Cormac, and he hasn't seen this question before. So what way would you think about going about this question?
I'm not sure, Jack. Could you just explain what way this is graphed here?
Okay, so this here, as you follow this link here, it comes out this way. We strike this distance here along this arc until it hits here. Then we strike this distance here until it hits the line P, and we create the graph going out this way. How this was broken down then is each section is worth 30 degrees, so it's divided down 30, 60, 90, 120, etc. all the way around. And then we step off equal distances of any length, so 5 or 10 millimeters would normally do, and label this 30, 60, 90. So our first point here is at 30, so it comes up here 30, so here's the point at 30 degrees. And then you go the whole way around, so let's say here it's at 300, so here's 300 on our graph. Let's follow that point all the way back, and it can be linked back to this point here.
Okay.